Hi, how's everyone doing? I'm Todd. I work for Cubist Systematic. If you've never heard of Cubist Systematic, we are the systematic trading arm of Point72. If you've never heard of Point72, we're a hedge fund in New York City, well, based in Connecticut, owned by Steve Cohen. And if you don't know who Steve Cohen is, he owns the playoff-bound Mets. And this is usually as far as I back this out for friends and family. So like, that's what you get. I work on the Cubist Core Research Technologies team. We sort of stand as an interface between a lot of like traders and quant developers and array cluster, be it one of our on-prem clusters or an Anyscale cluster. And we handle a lot of like questions from them. We're like, hey, like I want to do X and I can't do it. Like, can you build that out for me? The title of this talk is Raydar, Understanding Observability at Scale. I think there's also an extra part with minimal overhead. And like that's not on the slide because it looked janky, but like we're still going to talk about it. I'm hoping to motivate what Raydar is and why we built it quickly by example. So let's talk about the Ray dashboard for a second. The following is just a generic remote function, right? It's going to do a couple of imports. It's going to sleep for a second to simulate what maybe like real work would look like. It's going to like roll the dice for something, and maybe 10% of the time we'll just raise an exception and fail this task. And what we'll do is let's collect a list of references that launches this task maybe like 100 times or so, right? So if you're a developer and you've launched this to array cluster, your next question is like, what's going on? Like, are my jobs running? And you can usually open up the Ray dashboard. And when you do so, you get like this great breakdown of what's going on with your job. You get like these color-coded like different signals to say like you've got these jobs running, these jobs are pending, these jobs have failed. And if you work a little bit harder, you can dig down into some of these links and you can even find like worker logs to say like, hey, like I found some failed jobs, but like what was the stack trace? Like what happened here? Really handy. The thing is, if you're like some of the developers that we work with, they find out that they have like hundreds of cores and like tons of GPUs and all this horizontal scaling. And they say like, great, I'm gonna run all my tasks. Like, let's go crazy. So let's take like, for just like a hypothetical example, let's say we launch this task 500,000 times, right? And then you've got the same question, which is like, well, what's going on with all these tasks that I launched? Like, how are things going? And you sort of get a dashboard that starts off looking good, and then you get this. And you just sort of see like information about 10,000 tasks, but you've got 500,000, and this starts to like prompt some natural questions like, what's going on? Like, how is this happening? Also, if you refresh this, sometimes you get an even scarier message that says like, all of your tasks are unaccounted for, which is like, oh, and then they come to us and they're like, the Ray cluster is broken, something horrible has happened. I guess there's two like important reasons for this. One is that by default, the Ray dashboard caps out at 10,000 tasks. The other, and I might get this number wrong, is that the Ray GCS, which contains lots of task-related metadata and it runs somewhere on your Ray head, caps out somewhere in the like 25 to 50,000 task range. So like you might be sending more tasks to your Ray cluster, and at some point like it stops keeping track of like some of the older metadata that it might have, which is a bummer if you want to say like, hey, I ran this task a while ago, like what happened to it? And the GCS is like, I don't know, I saw that a while ago, I forgot about it. So we had to figure out some way to say like, how can we address this problem for some of these quant developers that say like, I ran this huge job, I think some of them failed, I don't really know which ones failed, I can't even find my error logs anymore because like my worker scaled down and I lost that worker. And so we built something called Raydar. There's supposed to be a really cool logo here on the right, but compliance didn't okay it, so just like imagine that white space looks like really cool. Here's like high level what Raydar can do. It can track hundreds of thousands of tasks, and it can do it live. So this scales like reasonably well. There's lots of utilities to do things like aggregations and persist your information about your tasks. It can do lots of interesting like user custom visualizations, which I think is what I'm hoping to have most of this talk focus on, because that's like the cool thing about Raydar. And it integrates really, really well into the Anyscale dashboard, and the setup is really, really minimal. So since it's minimal, let's just start there. As far as the setup goes for Raydar, you really only have to do two things. The first is it's a package on PyPy, so pip install it, that's one. And then you have to figure out a way to get it into your Ray cluster. You can either do that by uploading it as a Py module in your runtime environment, you can bake it into your image somehow, you can add it as a pip argument when you connect to your cluster. You've got a couple of options. Either way, it's like 2 lines, like you don't have to do a ton here. So now let's take that example that we had previously and let's talk about like how Raydar could interact and like solve some of these problems that we have, right? So everything is the same, but now we're going to import this class called the Ray Task Tracker, and let's just default initialize it. And then we'll tell it like, hey, process all these references that we're holding. And this now suddenly exposes a bunch of useful helper functions that like are kind of interesting. Like you can do this task tracker get data frame call that gets back to your client this big polars data frame with like all this information that should normally be stored in the Ray GCS. So you've got like task information, you've got like worker ID and like function name, and maybe you have status, and maybe you have like exception and like stack trace information if like that's applicable. It's cool. And you also have the option to save this data frame somewhere. Like maybe you want to save it to the cloud, maybe you have like a mount somewhere, maybe you want to like save it to like a local file. You can persist this information. And you can clear it, because like otherwise this is a memory leak risk, and like that's like no great. I guess this is like vaguely intriguing, maybe, but it's like this kind of stinks. Like it seems manual. Like what if I want to interact with it a lot? Seems like I'm sending like a big data frame over the wireless. This seems suboptimal and like not very fun or interesting. So you're right, and this is where we're going to introduce like a new component of this like Raydar Ray Task Tracker object. We are going to set this parameter which indicates that we are enabling a perspective dashboard. I don't know how many of you have heard of Perspective before, but it's got a great website. Perspective is this like analytics engine which offers lots of like really cool visualization options, especially for large data sets and for streaming data sets. This GIF that you're looking at is a bunch of the examples that they have on their website. So if you fall asleep during this talk, definitely check out their website, because like they've got really, really cool and useful and interesting looking graphs. Lots of different types of charts, different like on-the-fly aggregations that we'll talk about a little bit. Under the hood, the idea is that Perspective allows you to define some sort of like table schema in like its backend, and then you can update that table via like either a JavaScript call or like a Python call. It's got like a reasonably flexible API. And then it also exposes like the front end component, which lets you like look at that data and visualize it in interesting ways. So now if we're running what we just saw before on port 8000 on your Ray cluster, you're suddenly getting this as your tasks run. It's like, oh, cool, like interesting, it's live. I'm not like downloading data like over the wire. Like that seems nice. It's the same information that otherwise was somewhat contained inside of the data frame that we talked about earlier, but you know, at least it's not like something that I have to like go and like set up and download or like save somewhere. Like we can just kind of like hit like a port on our cluster and like see it, and that's kind of interesting. But admittedly, this is still like, how does this solve any of the problems that we talked about earlier? Like I can't look at this and understand like what my jobs are doing, how things are working, like so on and so on. So it's probably a quick time to talk about like what Perspective can do. Perspective has lots of different charting types. It's got bar charts and tree charts and heat maps and pie charts and all sorts of like interesting things that you can graph. It's got like aggregation options and groups and sorts and filters, which is, you know, like reasonably helpful for any like UI that you might want it to apply on top of data. It also has a reasonably good expression API. So if you have a lot of different columns in your table, you can on the fly do like aggregations, you can do interesting computations that like maybe you care about. Here, for instance, the GCS logs your start and end time in milliseconds, but it actually does it in strings. So if you like do like a cast, take a difference, divide, like all of a sudden like I have like a more useful column that like maybe I'm gonna call like seconds that it took my job to run, which is like, oh, like cute. So for the sake of like illustration, let's also introduce a second remote function called my other remote function. It's going to be almost the exact same thing as we had previously. The only difference is like now maybe like we'll simulate work by, you know, rolling the dice, and we'll sleep for like a unset amount of time. And we'll also like toggle the parameters by like how often this task will fail. Now like let's say that like if it's like 60% of the time, let's just like have it fail, throw a separate exception message, and like that's fine. Let's launch 500,000 of those too, and let's also tell our task tracker to process this information. Now you can suddenly build interesting charts that might actually help you solve like some questions that like maybe you were wondering about. On the bottom left-hand side here is still that like familiar table that has all the generic information coming out from the GCS. But on the top left, you've got a breakdown per task, per function type about like what your like success failure rate is for these tasks. On the bottom right live, you're seeing how long it took each one of these tasks to like die or succeed. And on the top, we get a breakdown of like exactly what exception messages are being thrown and like live and how many. So you can like show up to this scroll, see like exactly what's going on. And like maybe now that if you're running like many tasks, you can get like a live on the fly answer to some questions about like, why are some of my tasks failing? Like, do I need to like, is there like a weird edge case that like my jobs are hitting? And this can help you address some of those. I'm hoping to provide a couple of like hopefully compelling examples that you can, like of things that you can do with Raydar. The first one is Grafana-like metrics. I don't know if you've ever poked around the metrics tab on the Ray dashboard, but if you go into the Grafana view, you get a lot of really interesting cluster level breakdowns, right? Like you get like network and CPU and like task and actor level breakdowns, like all really cool, really useful and interesting stuff. Like maybe you have like some like particularly nasty job that needs like some very specific debugging, like maybe this is a place that you should go, and you should. Grafana is awesome. The only downside is, let's say that you're doing this on like a company cluster or like something that you don't really have access to. Setting up Grafana like takes some time. It takes doing. You just have to, which isn't a bad thing, and it's something that you still should be doing. But like, what if you're in a hurry and like you don't feel like doing it, right? Well, fun fact: if you look at your Ray nodes and you inspect your node manager address, and then you look at your metrics export port, and you hit that on your cluster, you can actually get like this big wall of text of Prometheus metrics that like you look at, you're like, what is all of this format? Like this looks like really, it's a lot. It's ultimately the same data that you're seeing in Grafana, and you can write parsers for it, and there exist like open source parsers for it that are like great. So we figured like, hey, why don't we just take this endpoint, take the parser, use this Prometheus endpoint that we now have, and let's publish all of these metrics to like our own tables, and then like let's just use that data in a perspective dashboard. And that's what you can do. So just set this parameter, and all of a sudden, under the hood with like no real extra work, you're doing so. And that lets you build out like interesting looking charts like this. We now have like cluster level state distributions across all your tasks. You have like what functions are running on what node IP, what like CPU usage looks like across your cluster. It's interesting. Like it's not like a built-in replacement for Grafana, but like maybe you have some very specific thing that you want to inspect quickly. Like this is a user-definable option. Quick plug for Anyscale, which is if you're an Anyscale cluster, everything that we've talked about so far and will talk about for the rest of this talk works really great in Anyscale. Anyscale, if you open up their UI, they have a ports option on the tab. And if you're running Raydar and you click into that, you like instantly get a link to this UI. So you don't have to worry about like, how do I hit a port on my cluster? Like, how do I worry about like, I don't know, reverse proxy forwarding or something on like some fancy cluster that like I may or may not have any access to. I want to move way away from that and go more into custom user stuff because I think this is a little bit more interesting. But to talk about it, I think we should maybe break into the back end of what's going on with your Ray task tracker in the first place. More or less, it works kind of like this. If that stick figure is your client, when you initialize a task tracker object, you're actually interacting with a handle to an actor which lives on your head node, and that's just the Raydar actor. And that actor owns this like callback actor handle, which is like doing a lot of the task processing. That callback actor is interfacing with the GCS, which is saying like, hey, like GCS, here's this list of tasks. Like, do you know information about any of them? If you do, I'm going to send them back and like publish that out to the user. And then all of these things ultimately are interacting with RayServe, some sort of like proxy service that like hosts something that like you care about from your UI perspective. You might also think like, I don't really care about that part. Like the GCS part is not especially compelling to me. I would rather just do this. I just want some sort of interface to like, give me an actor handle. I want to make my own tables. I want to publish my own data to my own tables and then expose that somewhere. And that's super reasonable. Another reason that the actor piece is kind of important is if you have an actor, that means that you can fetch that actor handle really from not just your client code, but it could also be inside of like an arbitrary remote call. It could even be in like a torch train object or like a ray torch trainer object, because all of these things really just need to use ray.get to interface with your actor handle. So that's important, and we'll see why in a moment. So let's introduce a new task tracker. We'll still enable the perspective dashboard, but this time we'll give it explicitly a name and a namespace. And we have a bunch of utility functions to do things like create and update tables. So let's create a table. We'll call it like the goofy demo table, and we'll just give it a bunch of table schema. We'll ask for a worker ID, a string typed, a metric value, an int, some other metric value. We'll just make that a float typed, and some like timestamp date time. Okay. If I now have a remote call that maybe I care about and maybe I generate some data for on the fly, I can do a couple of things. The first is I can initialize a new task tracker object with that same name and namespace. Doing so allows the Ray task tracker under the hood to fetch that handle that it has to the actor. And so like without actually recreating anything, it just like knows where this object is and it knows how to create it because it knows how to fetch that actor from your cluster. Sorry. Let's also do a couple of other things in this function. So let's pretend that this remote call takes a parameter I, an integer parameter I, and let's say that we'll just like hard code this worker ID as like a string for now, because this was my local cluster. The metric value, we'll just make it whatever we pass, so I. And this other metric value, we'll make it like I times some noise, so like something a little bit noisy, right? And we'll just say that like the timestamp is whenever this task runs. If we run this, now all of a sudden in our UI, we have the ability to look at our tables and kind of compare that metric value and other metric value as these tasks run live. So the one side looks kind of exactly what you'd think. It's just like a linear bunch of lines going up over time. And the other is sort of the same thing, but like interspersed with a bunch of noise. This isn't really like a compelling or like exciting example, but like hopefully it prompts the idea that like if I have data that I care about in remote tasks, I can publish that live and I can do this like at scale if like I feel like digging into something. We were thinking about other interesting and cool examples to do with Raydar, and we were like, what should we do? And we're like, crypto. And it's like, no, we're going to do ML instead. So let's get into like the ML example for this talk, right? If you've ever looked at the PyTorch Lightning code, there's a way to define your own custom logger. And like more or less the documentation says, interface, like here you go, implement this, and you have your own custom PyTorch logger. There's a lot of methods here that like aren't like either super interesting or they're like optional, so I'm going to mostly ignore those and just focus on these highlighted ones. More or less, the log metrics option is saying like, I'm going to hand your logger class a dictionary of metrics, like do something with it. And like oftentimes you publish that to like a log handler, like you do something interesting with it. It seems super reasonable to say like, hey, that seems to fit the paradigm that we've built with this like task tracking object, right? So let's define our own custom logger. And I'm going to hand wave here. I'm missing a function, but like it was too big to fit on the slide anyway. What we'll do is we will pass our custom logger a instance of our Ray task tracker object, right, in construction. And then when it comes time to log metrics, just tell my task tracker to update the table that we care about. Let's call it like my metrics table with those metrics, right? So now all you really need to do is three things. One, you initialize a task tracker, give it like a name and a namespace if you want, like maybe that's useful. Initialize a table that you care about for perspective. So define some metrics table, give it like some schema for some metrics that you feel like implementing from within PyTorch Lightning, and create your logger. Now, if you're implementing a PyTorch Lightning module, you can use the self.logdict function, which under the hood really is interfacing with whatever logger option you've defined in your PyTorch Lightning trainer initialization. So when you see something like that second line here, so I'm computing a loss in the forward step of my model training, and I'm building out this dictionary of like MSE loss and like what step I'm at total for the entire model training process and what worker ID I have. And I'm saying like send this to whatever logger you've got and like let it handle that information. So on the top is sort of how things would have been prior to any of this discussion. You build some sort of PyTorch Lightning model, you build some PyTorch Lightning trainer using that logger, using that model, and then you tell your trainer like, hey, go fit this. Now what I'm saying is do these things. Build a task tracker, build the table that you care about, initialize this custom logger, and then when you're building your PyTorch Lightning trainer, just tell it like use my logger. Don't use like the default logger, use mine. And if you do so, suddenly you get live visualizations like this on a Ray cluster. What you're seeing here is your MSE across your epochs. So different colors correspond to different epochs. And you can see like over time, like, oh, cool, like my model, it's learning some stuff. And like maybe this informs some stuff about like, I don't know, how many epochs you really needed to set in your trainer process. So this is interesting. I mean, taking this a single step further, if you check out the Raydar docs about PyTorch Lightning, and this is going to be a little bit hand-wavy, but it more or less says that like you can kind of write PyTorch Lightning code like the way you always have, but set like these extra 6 parameters, give it like devices and accelerator, like these blue parameters here, right? And what that'll suddenly let you do is it'll allow you to take a PyTorch Lightning model and train it on a Ray cluster, and like distributed in a distributed way with like multi-GPU, which is really cool. What I'm saying is, like, if you just take this one tiny step further and you add that logger object that we had previously, suddenly you now have like distributed metrics computation and like UI publishing baked into everything that you were already doing here already with like a single line of code. Like that feels like easy enough to do. So if you do this now, you get that same degree of like worker of like loss metrics, but now instead of like broken down by epoch, you get it broken down by worker, which is like, it's kind of interesting. And like, hopefully this is like slightly more compelling. What I was going to say is that I think I sort of am burying the lead here with the introduction of Raydar being like, hey, like, doesn't the dashboard like break sometimes? Like maybe we could fix that. I don't really think that Raydar is a good drop-in replacement for the dashboard or for like, you know, TensorBoard or for Grafana. I think where Raydar is really good is it's good for like saying, I have this very specific custom use case that is like a weird edge case for TensorBoard or for Grafana or for the dashboard already, but I really want to see it live. Like it's really going to be something that I would love to be able to see as my tasks progress. And I also don't really want to spend a lot of time setting this all up. So here's like a real example of that very thing. At Cubist, we were training like a really big model on lots and lots of data with like 40 different GPU workers at a time. And a lot of questions were like, why is this taking so long? Like what is happening at scale here? And so like we defined this, we kind of walked through everything that I just did here, but within a array torch trainer object. I'm figuring out how to like publish the data that I care about. And now I have this UI that like I can watch live and I can kind of see my loss curves go down across my workers. I can get a breakdown of like how each trainer process is spending its time. It turned out that like data loading here was kind of a lot. You get this nice chart with like all these different like color codes and you can see like whether or not like one or two of them was like spiking for weird reasons at different times, which like helped us figure out like, okay, we probably need to figure out some network changes, which is nice. And it also helped dispel this myth that we were thinking that, oh, like perhaps as we do distributed training in PyTorch, maybe like some of the workers are getting like stuck and like maybe there's like a weird like fan in, fan out process. And we were able to look at this and realize that like, no, it's actually mostly data. Like all the workers are like actually kind of running through their loops and updating and going to their next stages like reasonably quickly. Raydar is in like pretty active development and we really like updating it because we open sourced it. What you're seeing here is a lot of users were telling us that, hey, I spent all this time going through your UI and building out these charts and like handcrafting all these custom visualizations. But then if I terminate my cluster, like, oh, this all goes away. Like that's a really crappy user experience. And it's true. So like we built this quick thing to say like, hey, like wouldn't it be nice if you just hit a button on the top right and it saves your configuration? And if you felt like restoring it, just like drag and drop it into your window and like get things running again. It's nice. And it's just one of the ways that I think that we as a group are kind of committed to saying like, yeah, like we would like this user experience to be good because like we like contributions. We like people like showing up and like adding things to our repos. Like this is hopefully this is a good sign for people who are thinking about like, I'd like to poke around in your repo. That's mostly it. Thank you for coming. I know there's a lot of like other really cool talks right now, so I appreciate it. Here's our GitHub repo. Check it out. I think that we like stars, so if you feel like starring it, please do. Like and subscribe. I think that if you have some like issues, like please feel free to raise them on the GitHub page, and we like addressing them. So we're not super gatekeepy about PR, so if you feel like changing something, like put it up, and we enjoy it. Are there any questions, anything like that? Yeah?
What's the rationale behind using perspective as a primary?
So the question was, what's like why perspective, right? So perspective, I think a couple reasons. Like one is that one of the people that we worked with has a lot of experience with it, and like that was like, hey, like that's a tool that like I think I can help use build this stuff. The other is that I think it's scaled like surprisingly well for our use case. Like it does some like tricky things in your browser under the hood with like trying to keep like rendering a little bit like sane. So you can say like, I'm gonna tell the Ray task tracker to process 250,000 tasks, and like that doesn't like cause your dashboard to explode. Like you can still see like meaningful stuff as you go. I think that was mostly it. Yeah.
Okay.
Yeah.
In our HPC, we don't really have the opportunity to check stuff live. Is there a possibility to have like some kind of report at the end of the training using Raydar?
So what do you want to do ahead of time?
So basically, we cannot check stuff live. So we would like once the training has finished to have a report
Oh, so you want to run some stuff, publish it to Raydar, and then like you want to like be like a human in the loop and be like, do this, and then like your job continues?
No, like once the job is done, you have the report.
Oh, like an automated report. So I guess in the sense that like the UI exists and it'll be there and all your data will exist, it just won't be updating. So not in the sense that there's like, you can always print it out as like a PDF or something, I guess. There's also an export option in Perspective that's like save all of my tables and all of their data to some like local file. And then you can interact with it that way too. But there's not like an out of the box way to say like, generate me a LaTeX doc with like all this cool stuff in it right now. So open it as an issue on GitHub. Yeah.
You mentioned that Raydar supports ingesting metrics from Prometheus also, and you can compare it to the Grafana. How would you compare like the pros and cons of the Grafana UI versus the
So from a scaling perspective, I think they're both going to be really good. I think the only difference is, what if you want to come to Grafana with like your own custom metrics? Like I don't want to use like something from like your node manager port. I want to like write my own custom stuff. And that's I think where the biggest delta is. Like I have my own tables, I have my own columns that I'm going to update and like see cool things about. That's I think the biggest difference. Yeah.
So earlier in the talk you mentioned you had that like clear method to prevent the actor from using memory forever. If I was running like a long persistent query cluster, do you have some built-in way to make sure that you don't just like leave memory forever? Like should I just run that
So
regularly or?
I would run it regularly just to be safe, but there's like a way that Perspective does some of this stuff in like your browser storage, where like it tries to offload some of that to your browser, I think. Now if you're gonna ask me like more technical details on like how it's doing that, I'm gonna be like, oh man, that's really like the guy that I work with that knows that stuff. But like what you're saying is right. Like in general, you should probably be like saving and clearing these things just from like a sanity perspective and like sanitation, good like practice. So yeah. Yeah.
Does Raydar or Perspective have the ability to play back? Like,
Oh, like you want to rewind it and like see your loss curves go. Oh, that's a cool idea. Not right now. That would have been really helpful when I was making all of these GIFs, because I can't tell you how many times I had to like start doing it over. Not right now, but like again, another issue for the GitHub. Yeah.
Hey, so Raydar is something that's running on a local machine and connecting to a local cluster.
So your task tracker is like an object that you can hold on like your client. It's also something you can hold and own in like a remote function. Ultimately, what it's really doing is it's connecting to actors which live on your cluster. So that's the piece that like is like the heavyweight stuff, and that's all cluster side, not client side.
Okay, so I'm just asking, is there something you've done that living like a Raydar on the centralized service, like a centralized UI, then data scientists connect to that UI instead of running on the local host? Is that something you have thought about? And that UI kind of connecting to the, for example, I have a great cluster running on the Kubernetes and somewhere, and that UI just connects to the data source instead of I configuring any data source or anything. Automatically, everyone can see that live. Is that something ever?
Okay, so where's that picture that I had? So you're saying like, hold on, like cut this out. Like I don't want this at all. I just want the Raydar stuff to like open up some like RayServe application and like host the UI. It's very doable. Like we don't need the actor really. Like the actor mostly exists to do this weird callback hacky thing to like interface with the GCS. There's no reason that we couldn't make it even easier to just like launch the serve application. But as of now, like the API is more like build a task tracker, do something with it. I think like the bigger question is if you're using that like serve application, you have to be a little bit careful about how you interface with your serve stuff, in the sense that like what if you have like multiple proxy servers? Like how do you like update the right one at each time without like a weird conflict? Like that's where the actor stuff comes in handy, because like you just get the right name and namespace and you're updating the right tables in the right UI. Yeah?
Where do you see the data?
Sorry?
Where is the data saved?
So the data is owned somewhere in like realistically Plasma. And then it's also, there's something that Perspective does to leverage like storing stuff in your browser. But like realistically, it's on your Ray head, at least for a little while. The ideal is that like it's not really that much data, especially if you're already running compute loads that are in the like the 200, 500,000 tasks range, then like it's probably going to eventually be like enough data to be annoying, but like generally speaking, that hasn't been the case yet. Yeah.
I know Prometheus has its own like query language to customize metrics. I'm curious if Perspective has something similar and like how they compare there.
I don't know enough about its query language, but the Perspective query language has a lot of like, I don't know, it's have you ever used Scuba? Scuba's from Meta. Like it's the same kind of query language where it's like, I want to do some generic combination of columns. I want to take an average, a min, mean, max, that kind of thing. Yeah?
I have another question. Have you tried to use Raytune?
With Raytune? Yeah, so I'm going to fast forward. I don't know if you can still see that. Well, anyway, this example is with Raytrain, but not with Raytune. I think the only thing that we need to change with Raytune is you need to figure out a way. So like when Raytune like fans out and it's like going over all of its hyperparameters to do like its tuning, you would need to make sure that like each one of those processes owns its own handle to Raydar. To make sure that like each one of your separate processes is updating like the right thing. How does Raytune differentiate each process like under the hood?
That's the thing I don't know.
I don't either. I'm wondering if you have like access to like, I don't know, like a meaningful like string for each process to be like, this is this set of hyperparameters. It's like, and if you could, then then it's reasonable to like update us like the UI again with like.
Would you have access to the access of each of the data?
I don't know. That's a good question. Yeah.
In this example, is data loading via Ray data?
This very example is actually not. It's like this weird actor level thing that I was poking around with. We've used Ray data too. And there's no reason why we couldn't like figure out latency through Ray data with the same tool. Like especially you have like a custom like Ray data implementation, like yeah.
Like which data loader?
I wrote this weird actor thing that does a lot of stuff through S3. Like it's, yeah. Oh shoot, I gotta go. Thank you guys, appreciate it.